the James Webb Space Telescope has accomplished another meaningful task. Indeed, it has discovered 4 new galaxies, the farthest from Earth. Astronomers believe that these 4 galaxies are located more than 13 billion light-years away from Earth, considering them as a few of the early galaxies formed shortly after the Big Bang, and continue to study them. To understand these newly discovered galaxies, one must comprehend the concepts of the Big Bang Theory, redshift, and the expansion of the universe. The Big Bang Theory is one of several theories that try to explain how the universe came into being, and holds the theory that the universe explosively expanded after an extremely hot and dense body exploded long ago. We refer to this as inflation or rapid expansion. The expanding universe gradually cooled, allowing the formation and merging of diverse particles. This led to the synthesis of protons, neutrons, electrons, and the creation of various atomic nuclei and atoms. Basic elements like helium and hydrogen began to form. At this point, these elements were in their neutral states, causing the early light to scatter or reflect off these elemental clouds, preventing it from passing through. However, approximately 300,000 years after the Big Bang, gas and elemental clouds went through a process of reionization, allowing light to pass through them for the first time. From then on, we became able to observe the universe through light. About 300 million years post-Big Bang, gas and clouds coalesced due to gravity, forming the first galaxies of the early universe. Due to the Big Bang, the universe has been continuously expanding. By the 1930s, astronomers not only confirmed this expansion but also made a groundbreaking discovery: celestial objects farther from Earth were receding at a faster rate. They achieved this by utilizing redshift, successfully determining the receding speed of distant celestial bodies. To understand why this redshift occurs, we first need to touch upon the Doppler effect. The Doppler effect is a phenomenon where, as an observer approaches a sound or light source, the wavelength compresses and shortens, while conversely moving away from it results in a lengthening and dimming of the wavelength. It's much easier to understand when you think of it like an ambulance with sirens passing by us. When an ambulance approaches, the rising pitch of the siren is due to the sound wave shortening. Conversely, as the ambulance moves away, the pitch lowers, resulting in a low, elongated sound like whoom. The same phenomenon occurs when observing light. If a celestial object is approaching us, its light waves shorten, making it appear relatively bluer. Conversely, if an object is moving away from us, the light waves lengthen, causing it to appear relatively redder. Thus, redshift can be considered as the numerical representation of how much the light has shifted towards the red end when celestial objects are moving away from us. The significance of this value lies in the fact that through the redshift value, we can determine how far and how fast celestial objects are moving away from us. Astronomers were successful in observing the farthest galaxies using the James Webb Space Telescope's NIRCam. The NIRCam successfully discovered 4 galaxies by observing wavelengths in the near-infrared region, adjacent to the visible spectrum. The research team analyzing these 4 galaxies left behind a single-word verdict. The reason for the researchers' astonishment is that these galaxies were the farthest and oldest among all galaxies discovered to date. These galaxies were formed approximately 13 billion years ago, and considering that the redshift value is at least 11.7, which is more than 40,000 times the average redshift value of about 0.0003 in the universe. The discovery of galaxies formed in the early universe is not unprecedented. In 2006, there was a discovery of a galaxy called IOK-1 at the Subaru Telescope in Hawaii. This galaxy, with an age of 12.8 billion years, had a redshift value of 6.96. In 2011, using the Keck, Spitzer, and Hubble telescopes, GN 108036, aged around 12.9 billion years, was found with a redshift of about 7.213, setting a record. In 2016, a collaboration between Hubble Space Telescope's infrared observations and the Spitzer Space Telescope led to the discovery of galaxy GNZ11, approximately 13 billion years old, with a redshift value of about 11.08. Until that point, this galaxy was considered the farthest one observable by humanity. However, with the newly observed galaxies, the minimum redshift value is 11.7, and the maximum is as high as 13, providing clear evidence of galaxies much farther away. Furthermore, the researchers analyzed these galaxies' properties, finding that each has a mass only around 100 million times that of the Sun. While our Milky Way galaxy, part of our solar system, may seem relatively small compared to the Sun's mass of about 1.5 trillion times, it has been revealed that despite its modest size, star formation within it is remarkably active. The research team has established as their next goal the discovery of galaxies and stars closer to the Big Bang's inception. Considering that the galaxies discovered this time began around 300 million years after the Big Bang, there is hope for success in achieving this goal as well. Maybe one day, the James Webb Telescope will reveal our universe's origins.